Hi, I'm Ted Nelson. This series is leading toward a product design everyone can share. But in this video, I'm going to talk about past Xanadu versions because I'd like them to be appreciated, because I'd like all those people who worked on them to be appreciated, and to help provide momentum for the future system. Okay, to review. In the first video of this series, Xanadu Basics 1A, I gave examples of visibly connected documents which no one else is working. In the second video of Xanadu Basics 1B, I explained indirect hypertext, where content and links are brought in based on an edit decision or EDL. It's a fundamental structure that should be understood like Newtonian physics, an opposite way of structuring online documents, fundamentally different from everything else that's out there. The indirect hypertext document, which I explained in Xanadu Basics 1B, is a mix of content portions from different sources and separate links or XanaLinks, which are linking tables separate from the content portions. The XanaLinks are external to the content and applied to the content. In this video of Xanadu Basics 2, I also had Xanadu Basics 1C about parallel subjects and 1D about writing parallel. In this video, Xanadu Basics 2, we'll go over the systems I showed you in the first video, Xanadu Basics 1A, but in much more technical detail. This will be rather geeky, but you can skip entirely or just go to the videos. Now, there's a myth that my teams have never delivered. Contrary to that myth, my teams have delivered 5 different working versions of Xanadu hypertext. 4 of them got the Xanadu trademark. The one in Japan couldn't be called Xanadu at the time for political reasons. 3 of them are indirect, 2 of them simulate indirection. This will be an overview of those 5 Xanological hypertext systems, which are no longer actively in development. The good news is that you can run 3 of them easily. This is meant to be explanatory. We can't maintain a petting zoo of past working software. I have to apologize. These systems have been inadequately documented and have not been maintained at all. I've been unfunded and fighting the majority paradigm for most of my life, and I've had to move from place to place many times. In each situation, after moving to a new place, I've had to drop everything from the place I worked before. Hey, I'm an individual without financing, unable to persuade the world of these ideas. But still, as of this date, 20th of May, 2018, hanging in. Okay, we'll discuss these 5 systems individually. The 5 different systems have used different terminology and formats, but they've all been indirect, assembling lists of content, also called EDLs. Pardon me, they've all been indirect in principle. Assembling lists of content, also called EDLs. All but one of them then applied XanaLinks to that content. Each of these prototypes highlights different aspects of Xanological documents. You've seen brief clips of each in Xanadu Basics 1A. Now I'll show longer clips and give some technical details on each one. I won't tell them in chronological order, but in order of ease of explanation, starting with the simplest ones to explain. I'll leave the most complicated one to the end. I won't talk here of the many false starts and derivative endeavors we've been through. I wish I could have maintained an honor roll of everyone who helped me over the last 50 years, collaborators and well-wishers, families and lovers and patrons. Many of them are listed in my autobiography, Posiplex. In this video, I can just enumerate the main contributors to these 5 systems. Okay. First system. The easiest to explain because I have no pictures, nothing to show, and no tricky concepts that you don't already. The Hypertransaction system at Keio University, circa 1998 to 2002. At Keio University in Japan, I worked with a wonderful group of students and faculty at the Ohiwa lab on what was dubbed by them the Hypertransaction system. You can find it at Google. I wish I had pictures handy to show you. The Hypertransaction system implemented the whole Xanadu indirect model, which in those years I was calling transpublishing. I couldn't officially call it Xanadu then, but the trademark applies retroactively. It had a client and 2 servers, as I recall, a document server and a payment server. Here's what it did. An author could input and edit on the screen, composing a document either all new or with content from existing sources as well. The document would be represented as an edit decision list or EDL. This new, quote, hyperdocument, unquote, could be, quote, published. Once that first user had published the document as an EDL, others could pull it in. Another user could then send for the document, meaning the EDL. The new user's machine assembled the document for the EDL, applied the XanaLinks, and opened it for the user with sometimes micropayment for content, as implied by the title, Hypertransaction System. Contributors would be paid respectively by each downloader, for the portions received. Okay. Lost my cursor here. There we go. That payment part is what was called Hypertransaction. I didn't choose the title. It was as part of this project that I formulated the trans-copyright doctrine and licensed current version now at xanadu.com. Andrew Pam and I were co-architects of the system, but the official writing about it is by the Japanese participants. It was a big and beautiful job, a fully running prototype. The university and sponsors were very pleased. The university got serious funding for it from MITI, the Japanese Ministry of Trade and Industry, roughly $1 million, but I had no control of that. It essentially went for university overhead. According to MITI rules, the size of the documentation had to be proportional to the funding, so the documentation book that was handed to MITI was very, very big. I don't have a copy, it was in Japanese. But what a great job they did, both students and faculty. I believe it was considered a great success. Somewhere there are videos of it working, and I think the code may be archived somewhere, but reduplicating the multi-computer setup is not practical. I salute MITI, Keio University, Professor Ohiwa and his lab, and the students and faculty that made it possible, notably Professors Hajime Ohiwa, Kenji Naimura, Masatomo Togashi, and Jun Morai, and notably the programming of Yosuke Igarashi, if I remember correctly. It was a great experience and a nice package, and I wish it were out in the world. And by the way, I've confirmed this description with Andrew Pam, who agrees that it's correct. Second system to explain, OpenXanadu. OpenXanadu 2014. This is the simplest to use of the 4 working demonstrations. OpenXanadu, implemented with Nicholas Levin, a great guy who did a beautiful job working under a month's deadline, is our simplest and most accessible Xanadu system, which you can simply open in any web browser. It doesn't need the new oppressive browsers. OpenXanadu presents the origins essay by MoJust without Xanadu links. However, it shows transclusions beautifully, the source of every quotation. This is an essay called Origins, connected to its sources in an interactive page that you can open. Holding down the space bar continuously, I'll hold it down now, and using the arrow keys, you can step to the source of each quotation. Bibles are the products of centuries of theological struggle. Other vertebrate animals have been constructed on the same general model. The light blue portions are by the pseudonymous author MoJust, and the other colored portions are quotations brought in from their original sources and still connected to those sources, that is, transclusions. Note that column 4, just to the left of the main essay, contains the entire King James Bible, which is why it takes a while to load. The column just to the right of the main essay shows the additions by the pseudonymous author MoJust. Actually, the parts I wrote to tie all the quotations together. The title Origins is thus a pun. I suggest you play with OpenXanadu to get a feeling of how nice it would be to have the sources of all quotations handy. That is the principle of Xanadu transclusion. Not only is the quotation brought in from the original, what we call transclusion, but a direct visible pathway to that original is always available. OpenXanadu shows how easily it can be to go back and forth to any of them. Unfortunately, it's just simulating delivery from the original. It's not really an indirect document because it's running in your web browser, which does not allow text to come in from multiple sources. We've had to put all those sources at xanadu.com as if they came from elsewhere. It doesn't have to look this way, of course. The interfaces should be optional. Third system to explain. Xanadu Cambridge, or xuCamb, that I'm working on right now with Edward Betts in Cambridge, England. Edward is a brilliant programmer and a stalwart guy. What we demonstrate in this system, all of it actually working. A place to upload content. It works. A way to select text portions for your EDL. It works. A place to assemble your EDL. It works. A place to upload your ADL. It works. The edit decision list tells what portions to bring in and what links to apply. Using this list, you can open the XANADU we saw. Watch, I copy the contents. Now I'm pasting this list into the XANADU viewer. Click on Fulfill Document, and we wait a while. And we wait a little longer. And we just have confidence, and there's our XANADU with its connections. So there's the resulting XANADU with links and transclusions. It works. Xanadu Cambridge even has simulated micropayment with we're hoping to prototype the real thing. But of course, since we're doing it in the dang web browser, it can't bring in text from elsewhere. So it's not really indirect. Either we have to cache whatever you want to publish, a really lousy method. Edward is very careful and very accurate, and we can look forward to more from him. Rather than repeat the entire demo here, I suggest you go to my video New Game in Town on this very YouTube channel, which steps you through the whole thing. System number 4 to explain. Let's talk about the great Xanadu, which I now call Xanadu Classic. Xanadu Classic was designed by my team 10 years before the web in the summer of 1979, as described in my book Literary Machines. I managed to put together my dream team of 5 incredible guys. Roger Gregory was a brilliant eccentric mathematician and generalist. Mark Miller was a brilliant eccentric programmer and generalist. Stuart Green was a brilliant eccentric filmmaker and generalist. He'd been teaching holography when he was 14. Roland King was a brilliant linguistic theoretician, and Eric C. Hill at 15 was a brilliant young programmer. 15-year-old programmers were thin on the ground back then. Now, Xanadu Classic is more or less working. I'll show it to you again. But Xanadu Classic is unfortunately not fully documented. It could end up like the Antikythera mechanism, retaining remarkable properties that no one understands. It's all documented in principle. There exist my raw paper notes at the time and audio recordings of the meetings, which I maintained throughout the summer. But the work that they continued after that summer, especially in the town of King of Prussia, that's a town in Pennsylvania, is not written down or recorded. Xanadu Classic has a long, painful history. We didn't get it out on time, and the web came instead. In what ways our system might have competed with the web, we don't know. Mischievously, a special feature of Classic Xanadu, if you change a document, a link will remain attached to all the characters that are unchanged. Let's see you do that in HTML. Okay, Xanadu Classic is both an operating system and a document management system. Or rather, it is an operating system for all the drives it controls, with addresses for documents and links and versions. So here's your classic Xanadu disk with all that stuff on it. The classic Xanadu disk drive expects to receive raw characters, XANAlinks, edit operations translated by the input machine into rearrangements, instructions for the EDL, EDL requests from elsewhere in the Xanaduverse, for which it may provide links, content, or other information. Let's look at it again in the virtual machine that you can download from the Internet Archive. What you're seeing has 2 levels. The server underneath is Xanadu Classic, also called XU88 or Udenax Green. The upper level is a beautiful interface demo by Ka-Ping Yi, showing the relations between Thomas Jefferson's first draft of the Declaration of Independence on the left, and the final one that our fathers signed, dated the 4th of July, on the right. The gray parts on the left were deleted. The gray parts on the right were added. We're new in the final draft. Ping's interface is called Pixi, P-Y-X-I, standing for Python Xanadu Interface, up here. Even though this Thomas Jefferson demo seems to show only transclusions, not XANAlinks, the server does, of course, in general, maintain both XANAlinks and transclusions. This whole package, server and interface, with the beautiful Declaration of Independence demo, can be downloaded as a virtual machine. The zip file is 4 gigabytes. It works well in VMware Fusion. I don't know about other virtual machine engines. I regret that VMware Fusion is expensive. You can download the virtual machine from the Internet Archive. Address is on the YouTube page for this video, and the instructions are in that package from the archive. Once you've opened it in VMware, you need to revert to a former VMware snapshot, or you can also download the actual server if you know your command line, etc. I'm also giving the address for the Xanadu Classic server code. Okay, let's talk about the structure of Xanadu Classic. First, Tumblr addressing. Classic Xanadu has a unique addressing system for a new numbering system for specifying spans of characters and links that should be better known to computer scientists. For addressing documents and links, the team worked out a remarkable system of mathematics called tumblers, described in literary machines. A tumbler is a multi-part number, a series of integers beginning with 1 and separated by dots. The 1 is of significance for internal calculation. A document is specified by one tumbler. That is, the tumbler gives you the addresses of content to bring in, the edit decision list, or EDL. Now let's talk about how tumblers specify range or span in Xanadu Classic. Let's take a simple example. How you show a range or span in characters. You have two parts, a start and a length. Here's a character string, the quick brown fox. If you want to specify the word brown, the start is 11, and the span length is 5. This generalizes to tumblers. You have a start and a difference stated in tumblers. A tumbler pair can specify a span of characters to bring in, a span of links to bring in, a span of versions, a span of documents, or any consecutive combination. So the EDL and Xanadu Classic consists of tumbler pairs which specify spans of content or structure to bring in. Note that you can address many consecutive links with one tumbler pair, since we expected documents to share many consecutive links to the same content. This was pretty cute. A number of other properties directly follow from tumbler computation, but I won't try to get into them here. So where is the EDL in the demo you've just seen? It's in there. Let's look at it again. Here's Classic Xanadu viewed through Pixie again. The only sign indicating the presence of the server itself are the addresses at the top, here and here, which specify the two documents being shown. At each of these addresses is the EDL that brings in the document below it. The tumblers are low because this is a demo and we don't have much in there. On the left, 1.1.0.1.0.3, and on the right, 1.1.0.1.0.3.1.1. Those are the EDLs in tumblers. Okay, now enfilades. The 1979 Xanadu team also extended my earlier invention, the enfilade, which was an editable tree of text. As I originally figured out the first enfilade in the 1970 Xanadu project with Cal Daniels, the original characters would get rearranged by pointers, so editing was referential rather than direct. Make an insertion and the pointers would change. Make an insertion down here and the pointers above would change, etc. Do a rearrangement by creating a new arrangement of pointers. This allowed you to manage extremely large sequential documents without moving any text characters, as a unified system of pointers. This was our 1970 design when it was just Cal Daniels and me. Note that you can find the nth character looking down, and you can edit at the bottom, inserting new characters without bringing it all in. These properties were generalized by the 1979 team. In that fateful summer of Xanadu summer of 1979, my gang realized that the enfilade could be generalized to, quote, general enfilade theory, unquote. If you had a downward property and an upward property, they discovered that enfilade's downward property and upward property a countable sort of property from the bottom up, like inserting characters, and an imposable sort of property from the top down, like rearranging text. So my 1979 team created 3 enfilades in Xanadu Classic, but instead of counting by integers, as in the previous enfilade when Cal and I were counting characters in 1970, these enfilades count in tumblers. Okay, Classic Xanadu enfilade 1, the Granfilade. The Granfilade manages all the resources, the text, and all the documents and versions, quickly showing what disks they're on and where they are on the disks. It thus takes on some properties of a network some properties of a network operating system. Enfilade 2, the spanfilade. So spanfilades, the spanfilade manages all the spans of a document, text and links. A document spanfilade is the union of all its spans. To compare two documents, you find the intersection. Elegant. Okay, enfilade 3, the poomfilade. The poomfilade is an edit tree used for managing all the documents of the system. The poomfilade manages each new document as a permutation matrix of text and links. A permutation matrix represented in tumblers. The poomfilade generates the EDL of a specific document or version as required. I think you will agree, especially if you're a computer scientist, that my 1979 team, Roger Gregory, Mark Miller, Stuart Green, Roland King, and Eric Hill, came up with a brilliant and extraordinary design unlike anything else in the computer field. Okay, what Classic Xanadu needs. Classic Xanadu comes tantalizingly close to deployable. It would be very nice if the Classic Xanadu code could be topped off. It's very near working and it's an open source. I'm told it still needs bigger addressing. It was for the smaller disks of those days. A re-entrancy for multiple users, a federation code, the inter-server block, some socket changes for the current internet protocol, and 64-bit int so it'll run on the Mac. It already runs on Linux. It would be great if somebody would finish it. That's not my current thrust. Fifth system, in some ways hardest to explain. Xanadu Space, 2003-7. My favorite demo for the last decade has been Rob Smith's Xanadu Space. I designed a very simple interface for parallel pages, and many people have told me that they want to use it. How I wish they could. It's the richest visual implementation of indirect documents based on my radical design for a multidimensional viewer. Xanadu Space doesn't have an intricate addressing system like Xanadu Classic. It uses ordinary EDLs in current addressing space. But the client, the viewing program, is very tall and complex. It's extremely unconventional underneath, and to understand it, you must understand a number of different levels and objects. At the upper level, my standard demo, Xanadu Space, is a beautiful system for viewing the flight of connected documents. It runs on the latest Windows, Windows 10. So here are the directions, very simple, for the demo version. Here is the origins essay, which I originally wrote as a simple way to show the smoothness of Xanadu Space. You can fly around with the arrow keys. You can turn the camera with the control key and left mousing. There's a main page on the left with the essay called Origins. So we'll tilt the camera to see the top of it. By the pseudonymous Mojust, and a companion page next to the left page, next to the main page. Behind the main page and the companion page is a row of connected pages. We call this set of pages a flight. You can go back and forth between main page and companion page, making the main page into the companion page and vice versa, with the F and S keys. Now for the great part, you can step among connections, going to the next connection down with the C key, and the next connection up with the E key. In other words, F and S take you left and right, C and E take you up and down in this particular interface. You can bring up any connected page as the companion page, then switch focus to that, making it the main page. But the emphasis on this demo is on the central essay
called Origins by the fictitious Moses.
So that's what I usually show of Xanadu Space. That's all there is in the demo, and I invite you to try it. You can have a lot of fun with it. But there's much more. Actually, the system is much deeper. The user's program, the client design, goes very deep, representing a lot of my other ideas underneath. It's like Bucky Fuller's Damaxian car that pulled together a lot of Bucky's ideas, a climactic intertwingulation, you might say, which I would like understood. I also hope it will be a vindication in a way of a number of ideas that people have not understood. It not only has parallel documents assembled from an EDL, but it was built on my zigzag structure and has a multidimensional viewer, also based on zigzag. Sorry, zigzag's my other trademark. It's unconventional in every possible way, Xanadu Space, deeply continuing my main ideas. Xanadu Space was meant to be the culmination of my work. Oh well, parts of it work perfectly, every part of it has worked at some time or other. It's easy to say that this program, Xanadu Space, was too big a step, that I was starting from scratch for the third time. Okay, the Xanadu Space story. In 2003, Marlene and I moved from Japan to Oxford. We did no official software development there, but in England I found Rob Smith, who did the Xanadu Space system with me. I worked with some remarkable people at the Oxford Internet Institute, whom I've thanked in many places. But the person to thank for the Xanadu Space program is Robert Adamson Smith of Manchester, England. The project began in a railroad station when I asked Rob to explain how 3D software worked, in particular the OpenGL system, and I made some suggestions for combining it with my zigzag system of radical structure, representing each part with zigzag cells, and creating a new kind of multidimensional viewer based on zigzag, and then maybe using such a viewer to work with Xanadu indirect documents. Well, Rob caught fire on the idea. All of it. All of it. He understood and became enthusiastic about all the ideas I wanted to combine. The Xanadu document system with an edit decision list, zigzag, my construction system for non-hierarchical structure, a multidimensional viewer based on zigzag, with smooth motion in unusual directions. I called it swarfing because it could both make objects either swoop or morph. Rob was great to work with. He would come down on the train from Manchester to work together, wearing nothing but a t-shirt and pants, whatever the weather. Rob first delivered some zooming studies, and then version after version of the whole system. It's intricate. Rob used C++, Python, SDL, and my system Zigzag and Zoggle. Rob finally burned out. He used the term brain freeze, but anyone who looks inside will be impressed by the care he put into the project and his breadth of expertise. I've shown you my standard demo, with the swarfing documents and connecting beams. At the next level down, Xanadu Space uses the zigzag construction system to build a scene. In zigzag, or hyperthogonal structure, everything is in rows and columns at right angles. It's built from a lot of cells connected on lists that can be custom built into many different structures. Zigzag has been described in many places, and I won't introduce it here. Among other things, zigzag is actually an application builder. You can use it as an inner structure, a framework for any kind of application, and that's what Rob and I did here. An application based on zigzag we call an applitude. In a zigzag applitude, you design the kind of units you want, how you want them connected, and what properties you want them to have, and that's all changeable. Xanadu Space is a zigzag applitude with all structure represented by zigzag cells. Let's go inside it to see them. So here's the Xanadu Space we all know and love, with connection to sources and links in blue, transclusions in pink, and 10 companion pages, each of which can swoop up to be next to the main essay page. So that's the demo version, but there's so much more underneath. So if I hit escape, in this version we can see the zigzag structure underneath. We can step through it. There's lots of stuff down here. We could spend hours down here, but there's not really any point, because understanding the overall structure is the important thing. A zigzag unit can represent any kind of an object a document or a person, a car. It has a main cell and connected cells that determine its properties and relations. When you design a zigzag structure, a lot of decisions have to be made. As soon as you want to represent a particular kind of object, like a car or a person or a marriage, zigzag conventions have to be established. Okay, the viewer, floating world. The floating world viewer is a zigzag amplitude. The zigzag amplitude. For example, I wanted flying objects on the Xanadu space screen. I now call them flotons. Their properties had to include position, angle, color, and size in the 3D space. So a floton had to have those different properties. So each object you see on the screen is a floton. Each page and each beam of connection between pages is a floton in the zigzag structure. If the user creates a new document or page or a new link underneath in the graphic image, the graphic page, it's a new floton. It gets a new main cell and property cells inside the system, inside the structure. And all the properties can be tweened under user control through the zigzag mechanism. Our unique viewing amplitude is built around the standard 3D library, OpenGL, which has been standard in the industry for a long time for both scientific applications and gaming systems. But to manipulate OpenGL, we created a viewer that will project our flying objects from zigzag floton cells. I originally called them ViewNets, or for visible units. This viewer was originally called Zoggle for zigzag plus OpenGL. But now, we called it, in this system, we called it Floating World. We changed the name to Floating World, which was also a naughty term in Japan. A floaton object has numerical parameters in X, Y, and Z, spatial coordinates, represented as ZZDIMs, U, V, and W, angular coordinates, represented as ZZDIMs, and RGB in color space. All these can be tweened under user control. The motions we show are just one example, are just particular examples of that tweening. Note that zigzag dimensions, which are listing dimensions, as in spreadsheet or Scrabble, are being used to control Cartesian dimensions, which are the familiar X, Y, and Z of the world around us, as well as the familiar X, Y, and Z of OpenGL and other 3D computer spaces. Okay. That's an overview. Now it gets technical. How did Rob do our standard demo? Well, the way OpenGL works is that you position objects with coordinates in 3D space, right? So here's your 3D space, and here's your positioned objects. An OpenGL object is created from basic shapes that you wrap with a picture, which is also called a texture. You can't just fly a texture around, it's infinitely thin, and according to the OpenGL paradigm, it has to be on a box or a sphere or some other basic shape. Same for transclusion bridges, which are also pinned to pardon me, get to that. So the flat documents you're seeing in the standard Xanadu Space demo are actually textures pasted on very long boxes, which we call slabs. So Rob would typeset each document to a texture, then paste it on a slab, and then the connection beams would be put in place between the slabs. Actually, the endpoints of the connection bridges were what we called tetroids, named after the shape of the piece in Tetris, because it's also usually the shape of a paragraph. So the objects in the standard Xanadu Space presentation are slabs and beams. I now prefer the term bridges. And the beams are quadrilateral shapes connected to the corner points of tetroids pre-identified on the texture map. There they are, connected tetroids. So when a portion of text is a Xanadoc endset, in Xanadu we don't say anchor, we say span or endset. So Xanadu Space connects a span on one side, an endset on one side to an endset on the other, which is visually a tetroid. And that's just the icing on the cake. This simple presentation, the simplified interface I designed to present the origins essay, tetroids and quadrilateral beams, is only a small part of what's underneath Xanadu Space. For instance, Rob also did typesetting onto cylinders. that could also have connection bridges. And so here we created a conveyor, and we were planning a conveyor belt built through. Here's the cylinder with the projected text, and the beams, the bridges connected to the beam, to the cylinder, and continuations above and below the cylinder to make a sort of a conveyor belt view that could give you an overview of a huge document and scrolling through it while seeing the whole thing with all the connection bridges. It's also for creating and editing XANADOcs, though this feature has been turned off in the demos I've given. What happened to Xanadu Space? Rob sent more versions, some with editing, but unfortunately after leaving Oxford I had no time to deal with Xanadu Space further. We returned to a long-lasting family crisis in the USA and I couldn't work on Xanadu Space anymore. I wish I could document Xanadu Space further, but I've forgotten a lot of it. To document it would mean studying emails that are stored on I know not what. To document it would mean studying emails that are stored on I know not which computer prior to Gmail. There's also documentation to be studied among Rob's 50-plus deliveries. I believe that all the different parts of Xanadu Space worked at different times, zooming around, opening and closing pages and documents, editing, linking, transcluding, but which ones we don't know. But even testing to see which versions work and in what ways is probably undoable. Since Oxford, I want to thank John Ono and Jonathan Kopetz for putting in many months of work analyzing Xanadu Space and trying to bring it forward, for example, by dynamic typesetting directly onto slabs. One graphic library from Disney and Carnegie Mellon was very promising. The spec said it would do the job, but John and Jonathan finally concluded that it wouldn't. More recently, I want to thank Tim Johnson for working directly with the Python code of Xanadu Space, which raised interesting possibilities. It would be interesting to put Xanadu Space into open source, but who the heck could manage such a project is a very difficult question. And my main emphasis now is to work toward a simpler, shareable system. Okay, closing remarks. I have reviewed the complexities of 5 systems of documents that build XANADOcs from edit decision lists, only one of them without XANAlinks. Thank you.